Hello friends. So today I'm going to show you how to fit a function to a curve based on real data. So for example, I have this data here on Logger Pro, which is the charging of a capacitor in an RC circuit. It has a 22 microfarad capacitor and a 100 kilo ohm resistor. And here you can see the time and the voltage of the capacitor. It's just called potential here. Here's potential time on this axis. So we're just going to copy this data. So I'm going to click here on time, and then I'm going to click again on potential. I have to hold the shift key down to highlight both columns. And now I'm just going to do Command C to copy. Now I go over to Desmos. I already have a Desmos window open. And you can see some of the other things on my tabs that I've been working on. So I'm going to just do Command V rather, and paste the data in. And here you can see that the data has been dropped in, and I've got data over here. So I'm just clicking and dragging to move the mouse, to move the graph around. I'm going to put this down here because I want to use the whole scale of my screen. So I'm going to make it as wide as I can, sort of make it fit. The way I'm zooming in and out, I'm just using the sliding two fingers up and down on my trackpad, or I'm using the scroll wheel on my mouse to zoom in and out. Scroll wheel on the mouse is a little nicer if you can do it with a mouse, but two fingers on a trackpad works as well too. So I've got the x-axis about right, but now I want the y-axis to look a little taller. It's just so I can see things a little better. So I'm going to click on my graph settings, which is this little wrench in the upper right-hand corner, sorry. And my, let's see, I want the y-axis rather, to go up to about 4, because you can see this data comes up to about 3 point something. So I'm going to just change the top of my y-axis to 4, and that makes that look about right. And now I'm going to add a label to my x-axis. So my x-axis, as I recall, is voltage. So I'm going to say, no, that's not right. The x-axis is time. So I'll just say time, and I'll put in seconds here. And then I'll click down here to put a label for the y-axis. The y-axis, I want it to say v_cap. I don't have a way of doing subscripts here. Underscore ordinarily would make things a subscript, but it doesn't work right here. I'll show you that a little bit. But now we can see down here we have the time in the x-axis, and VCAP. I need to put voltage here, so I'm going to add parentheses, capital V, close parentheses. And now you can see up here it says VCAP V. All right, so I'm now going to click on the wrench to close this thing again. That looks about right. All right, so now I need to make a function that fits this. So I'm going to click here and make a new function. And I'm going to say y, I can't say VCAP, unfortunately. Y equals, so V battery. And to get a subscript, I'm going to again use the underscore, and then I will start typing BAT to get VBAT. And then I use the forward arrow to make it not be subscript anymore. Parentheses. 1 minus e, and the superscript is shift 6, which is a caret, e to the t. I can't use t here. It has to be x because I don't have the ability to get to time. That's going to be divided by, it would be divided by tau, but I can't do Greek letters on Desmos, so I'm just going to use a capital T. Now I want to make this be x minus T0, and you can just type a 0 to get a subscript for a single character like that. T0, just type 0 and it'll give you the subscript T0. And it needs to be all negative, so I'm going to go back here and put negative, e to the minus t over tau. That looks about right. And now I'm going to close parentheses. Now down here it gives me the option to add slider VBAT, T0, or T. I actually want all of those. I'm going to click on this all button, and now I get sliders for the 3 things. Okay, and I don't really care about the fit before we start charging. Obviously, we're not going to fit things very well there, but the important thing is to fit it after the time we start charging. So I'm going to start moving my time slider. I want to get right at the corner. Ooh, and I go from t equals 1 to t equals 1.2. It's really granular there. I want to be at somewhere less than that. So I'm going to click on this 10 over here, and that opens up this chart here. So I'm going to, my whole range here is going to be from t equals 1 to t equals 1.2. And I'm going to make the steps really small, 0.001. All right, so now I can adjust my slider a little bit to the, and now I've got a nice smooth motion. I can go right to where it starts to go up. The bat's going to have to be up higher, probably something like that. Again, this is very chunky, so I'm going to change this to maybe 3.1 to, oh, I don't know, 3.3 should be the range that I have here. Again, we'll do a really small range, 0.001. So I've got a slider again, and I can move that up and down. I'll fiddle with that later. And then the time constant, tau, which I've got with capital T here, let's go ahead and make that. Ooh, that actually looks really good, but it's still pretty chunky. I want to get a finer precision for this number than just a tenth of a second. So I'm going to go from 2.2 maybe to 2.6, step 0.001. I just want to go either side of where I am now. But like I said, this looks like a pretty good fit to start with. Wow, yeah, it's actually really good. So now I want to know just how good that fit is, and I want to be able to improve the fit just a little bit. So what I'm going to do, I want to know what the difference is between the data and the, I want to know what the difference is between the data and the function that I have just created here. I should be clear here. These data are not a curve, but they are individual points. The way I'm zooming in, again, I'm just using my scroll wheel on my mouse. So I'm zooming in. I can see these are individual points. Zoom back out. So this looks pretty good, but I want to see what the difference is between the curve and the data points. You can see when I zoom in that they are, at this point anyway, they're a little, well, a little below the line. All right, zooming back out. So let's go ahead and do y1, and I'm going to use the tilde character. So this is makes a function that we can do a regression on. You'll see that in a moment. I'm going to just highlight all this, and I'm going to Command C, come back down here and Command V. And now I have to change some of these things. No, the only one I have to change is X here. I have to make that X1. Okay. Now what this is actually doing is it's running a regression on all the free variables in this. And the only free variable I've given it is X, so it's not actually doing a regression. But what it will do is it'll tell us how good our fit is. We have an R squared of 0.914. And it allows us to plot our residuals. And the residual is just that difference I was telling you about a moment ago, the difference between the function and the actual data. So to get those data, I'm going to click on the plot button right here. Click plot, and suddenly we get a new set of data that looks like that. You can see these big black things. If I zoom in again really tight, you can see that they are clustered around 0. Which is sort of what you expect. You want the fit to be, the function that I've created to be running right through the middles of the dots. But you can see that we're a little bit off by a small margin. So I'm going to zoom back out, and I'll go up to the top here, and I'm going to make this a little wider so I can see that. So I just click on that. And now I'm going to make this, say, 10 times bigger, times, so I just use Shift-A to get times 10. And you can see that our spots or dots are a little bit higher. I actually want those to be even bigger than that. So let's try times 100. Ooh, that's really huge. So click and drag. Yeah, that's probably too big. Let's change this to 30. Oops, can't do that. Let's see here. 30. That looks pretty good. Maybe we can do, yeah, 30's fine. All right. So now you can see that I missed the, oops, I clicked down there. I missed the corner a little bit. There's a little bit of a drag down here. So I'm going to go back to my T0, which is when we started charging. And I'm going to try to bring that up so it's zeroed. Now you can see that makes this part of the curve go a little bit low. You can see the function is low here. So that means I want to make tau a little bit higher. Now this part of the graph looks like it's too high. So I want to bring down VBAT. So I'll come bring VBAT down a little bit. It's looking a little better. Let's go back and forth a little between VBAT and my time constant tau and see if we can make that work out a little bit better. All right. It's hard, as you can see here. Actually, this is pretty good. I'm going to go with this. So now what I've come up with, you can see that I have my VBAT is 3.199 volts. That's 3.2 volts, which is what we expect. The time I started charging, who really cares? It's the time we started charging. And then we have this time constant tau, which is 2.38 seconds. That tells us the time constant of our circuit. Okay, I think I'm done now. If you have any questions, you know where to reach us. Talk to you soon. Thanks a lot.